Today we can see the Morgan chopper. Morgan chopper is a single SCR chopper that employs class B commutation or current commutation or resonance pulse commutation. So the Morgan chopper uses a saturable reactor, so that will saturate for a low value of exciting current, after which it offers very low or negligible inductance. So this is a circuit diagram of the Morgan chopper. So this T1 represents the thyristor, and this is capacitor, and this is SR. SR is a saturable reactor, which is a very important component in the Morgan chopper. And we have a diode, and this is the freewheeling diode, and we have inductor and the load. So this is the component present in the Morgan chopper. So first we can explain what is this saturable reactor will do. So this is your saturable reactor, that is we represent as SR. So if I am giving the polarity as plus minus, then the current direction will flow like this. So this will be considered as a positive saturation mode. Positive saturation mode. So if the polarity changes from plus to minus, then the current flow will be like this. This will be represented as negative saturation mode. So we have a two mode in this saturable reactor, positive and negative. So next one is here for the saturate reactor, I have to consider two considerations. That is, the first one is when it is in saturation mode. Okay, so when it is in saturation mode, it offers the minimum induction. That is, more current will flow across the circuit. Okay, so there are two considerations we have to keep it in mind. So the first one is when it is in saturation mode, it offers the minimum induction, so that the current flow, it has so that inside the circuit we have the high current flow. And the second one is if it is not in saturation mode, then it offers the high inductance. Then it will resist the current. Again I am repeating. So in the under the saturation mode, we have first, if it is in saturation mode, it offers the minimum induction. If it is a minimum induction, then there is a possibility of current flow across the circuit is more when you compare with the non-saturation mode. If it is a non-saturation mode, then it offers the high inductance, so there is a possibility of resist the current. So that is a working principle of this SR, saturable reactor, where this overall circuit will follow this concept. Okay, so next we can go for the concept. This is again, this is a circuit of the Morgan chopper. This is the waveform where we are going to draw it. So first we are considering across this thyristor, the voltage across this thyristor is considered as VT. Okay, and voltage across this capacitor is considered as Vs. Okay, so the first one is IDS. So we have different modes of operation in the Morgan chopper. So in the first mode, I am considering SCR is off. When SCR is off, the capacitor will start charging. So when SCR is off, the capacitor starts charging and the output voltage will be 0. Okay, so first initially there will be no IDS, that is SCR is off, and for the voltage across this thyristor will be on. Like it will go to the Vs, it will take the voltage Vs, and the voltage across this capacitor also, it will take the Vs, and the output voltage is 0 here. The output voltage is 0. So this is considered as the, up to this across the current I will tell later. So this will be considered as the SCR is off, when SCR is off. Okay, and the second mode, we move on to the second mode. So once the gate pulse is given to the thyristor, then SCR will get switch on. So SCR is on, that is we are giving the gate pulse. So this is gate pulse. So once we give the gate pulse to the thyristor, then the SCR will get switch on. Okay, so once the SCR is getting switched on, so this across this capacitor, the polarity will be positive, negative, and for the SR, the polarity will be positive, negative. So if it is positive, negative, the current flow will be inside this circuit. And what about the entire current flow across this is this will be the entire current flow when SCR is on. So this will be the entire current flow. So when the gate pulse is given, and what about to this VT? So when SCR is on, so it will move on to the zero voltage. Okay, this will be SCR is on. And what about the VC? So this VC is again, it will be move on to till it is in, because here we have the current flow across this saturation mode, across this capacitor also. So this will be considered as a positive saturation mode. You can see the polarity plus minus, so I am telling this is the positive saturation mode. And what about this output voltage? You will get the output voltage when SCR is getting on. So when SCR is on. Okay, so again I am repeating, initially it is SCR is off. If the SCR is off, the voltage across this thyristor, you will get the voltage, that is Vs, and the capacitor also is getting charged, that is Vs, and the output voltage you will not get, it is 0. And when the gate pulse is given to the SCR, then the SCR will get switch on. On that time your thyristor voltage across will get 0, and the Vs, that is the voltage across this capacitor, it will move on to the positive saturation mode, and the output voltage also we will get across this SCR when it is in on. Okay, so this will be considered as a second mode. And what is the third mode of operation? So when the third mode of operation, for this third mode of operation, as I told you, like saturation occurs, right? Saturation occurs inside this saturation reactor. So what will happen? This polarity will get changed from, I will take the another color. So this polarity will get changed from positive to negative. Positive to negative. Again, this capacitor polarity also will change from positive to negative. So if it is flowing, means the current flow will be flow from this direction. So what will happen? This will be considered like this voltage, threshold voltage will be continue. But what will happen to this capacitor voltage? Because the polarity got changes, and it will move on to the negative saturation mode. This is the negative saturation mode till the SCR is switched on. So you will get the output voltage across this. Only thing is, even the SCR is getting on, the only thing is the saturation mode will be changed. The polarity, due to the changes in the polarity of the saturation reactor, it will be move on from the positive saturation mode to the negative saturation mode. So that is what you have to keep it in mind. Okay, and what will happen to the fourth mode of operation? So under the fourth mode of operation, so this SCR will get switched off again. What is the reason? Means because the current flow through this SCR is below the holding current. So if the current flow across this thyristor went on below the holding current, then the SCR will get switched off. So now we are going to see what will happen when the SCR is switched off. So when the SCR is switched off, so there will be a voltage across this thyristor. So that will be considered as this one. So it is getting on. So this condition is SCR is off, and here you will get the voltage, that is capacitor voltage. And what will happen to this output voltage? You will not get any output voltage when SCR is off. So this is a off condition, and this is off condition. So this is the explanation about this. And what will happen to the current? So the current I am just considering as a constant. I am considering as the constant here. You can see like during this condition, you can see so you can see during this condition, that is it is off, that is SCR is off, then SCR is getting on, and again SCR is off. But even though you are getting the current, what is the reason? When SCR is off, the current flow through the forward wheeling diode. When SCR is on, the current flow through the SCR. Okay, so there are two considerations. One is when SCR is on, it will get the current flow through the SCR only. If the SCR is off, the current flow through the forward wheeling diode. So that is this is your forward wheeling diode. Okay, so that's all about your Morgan chopper. We have four modes of operation. First one is SCR is off. When SCR is off, you will get the threshold resistor, and VC is you will get the VC to the VS, and this negative will be considered as minus VS, and you will not get any output voltage, but you will get the current due to the forward wheeling diode. And next one is next mode of operation is SCR is getting on. When SCR is getting on, this positive saturation mode will occur, and you will get the output voltage, and the current will be flow through the SCR. And again it is getting on. This is third mode of operation, but during the third mode of operation there is a change in the polarity in the saturation reactor. That is, it will change from the positive saturation to the negative saturation mode. So this is the negative saturation mode, and during the negative saturation mode, even till the SCR is getting on, so that is why you are getting the output voltage, and you will get the current also. The current flow through the SCR will happen here. And after some time, when the current in the thyristor is below the holding current, then the SCR is getting off. So when it is off, then your voltage will be 0, and again there will be a current flow because of the forward wheeling diode. So these are the four modes of operation. This is the first mode. This is the second So this is the first mode, and this is the second mode, and this is the third mode, and this is the fourth mode. Thank you.